Why are non-Newtonian fluids hard to pump? Imagine trying to push a thick, sticky substance through a tube. Now, picture that substance changing its thickness as you push. That's what makes non-Newtonian fluids so tricky to handle. And like water, which flows smoothly no matter what, these fluids act differently depending on how much force you apply. Their viscosity, or resistance to flow, can go up or down based on how hard you push or stir. This makes pumping them a real puzzle for engineers. Take ketchup, for example. When it sits still, it's thick and hard to pour. But when you shake or squeeze the bottle, it becomes thinner and flows more easily. That's shear thinning behavior. On the flip side, some fluids like cornstarch mixed with water get even thicker when you try to stir or punch them. This is shear thickening behavior. These changes happen because the internal structure of the fluid rearranges under stress. Now here's the challenge for pumps. Pumps are designed to move fluids with a steady resistance. But with non-Newtonian fluids, resistance can suddenly spike or drop. When the fluid is at rest or under low force, its viscosity can be very high. That means it resists movement strongly, making it tough to get started. Once the fluid begins to flow and shear is applied, its viscosity might drop, easing the process. But getting it moving initially requires a lot of pressure. Standard pumps like centrifugal types aren't built for this. They struggle to adjust pressure and flow in real time as the fluid's viscosity changes. This can cause the pump to work inefficiently or even break down. The flow inside pipes also becomes unpredictable, with increased friction and pressure drops. To keep things moving smoothly, engineers often use special pumps like gear pumps combined with variable frequency drives. These can start slowly, shear the fluid to reduce viscosity, then ramp up the flow. In industries like food processing, mining, or even cosmetics, handling non-Newtonian fluids means designing equipment that can adapt to these odd behaviors. It's a fascinating challenge that pushes the limits of physics and engineering. So next time you see ketchup or slime, remember, their strange flow properties are a scientific oddity that makes pumping a real science puzzle.